Bienvenidos a la Universidad Militar Nueva Granada. Preste atención a las siguientes recomendaciones en caso de emergencia. Atienda siempre las instrucciones del personal de seguridad y de brigada. Son quienes le indicarán qué hacer en caso de presentarse cualquier evento. A ellos puede informar acerca de cualquier anomalía que usted detecte o en caso de presentarse alguna emergencia médica. Usted se encuentra en el aula máxima. Identifique la salida más cercana a usted. Estas se encuentran debidamente despejadas y señalizadas. En caso de sismo, mantenga la calma. Permanezca en el sitio hasta que pase el sismo. Ubíquese en posición fetal frente a su silla. Hágalo doblando la cabeza con el cuerpo pegado a las rodillas y ubicando las manos detrás de la nuca. Solo en caso de que la evacuación sea inminente, se activarán las alarmas de evacuación tipo sirena o silbatos, los cuales sonarán indicando que se debe evacuar. En caso de presentarse conato de incendio o si percibe humo en el recinto, evacúe el sitio cubriéndose la boca y nariz con un pañuelo o su mano. En todos los casos, esté siempre atento a las indicaciones del personal de seguridad y brigada de la universidad, quienes lo guiarán hasta el punto de encuentro ubicado en la Plaza Cervantes. Para su tranquilidad y la nuestra, la Universidad Militar cuenta con los recursos necesarios para la atención de posibles emergencias. Estamos preparados y seguros de que su permanencia en nuestras instalaciones será de su completa satisfacción y seguridad. Recuerde, ante cualquier situación de emergencia, mantenga la calma, porque la clave de la seguridad somos todos.
Nuevos retos, nuevas oportunidades.
La U para estudiar, compartir y crecer.
Aquí, mis metas son más grandes.
Estudiar en un ambiente natural.
Mi ruta hacia el éxito.
Mi proyecto hecho realidad.
La militar soy yo.
La militar eres tú.
La militar
Somos todos.
Buenos días. Primero que todo, muchas gracias por asistir el día de hoy a esta conferencia. Esta conferencia es organizada por la Vicerrectoría de Investigaciones y la Editorial Neogranadina. La idea es que, que sea una evidencia más del trabajo que venimos realizando desde la editorial y cómo la editorial pues, puede apoyar procesos de formación en investigación. La conferencia es de un tema pues, de alguna manera novedoso y muy interesante y muy útil, y es cómo los gráficos, las ilustraciones, bueno, todo lo que se usa en la literatura científica puede servir para construir argumentos. Y para eso nos acompaña el día de hoy la profesora Lynda Walsh. Voy a rápidamente leer el perfil de la profesora Lynda. Ella tiene un PhD en inglés en la Universidad de Texas, con una línea de especialización en retórica y composición. También tiene una maestría en lingüística de la misma universidad y tiene un pregrado en inglés con una tesis summa cum laude. Desde hace más de una década, Lynda ha venido publicando artículos, capítulos de libro y libros sobre retórica de la ciencia y retórica visual, que son sus líneas principales de investigación. También es autora de algunos libros destacados, como uno que se llama Pecados en contra de la ciencia, las bromas científicas desde Poe, Twain y otros, editado por la Universidad Estatal de Nueva York. También Científicos como profetas, editado por la Universidad de Oxford, y Topologías como técnicas para una retórica poscrítica de Palgrave Macmillan. Pues la profesora es experta en todo el tema de retórica, con un énfasis en divulgación científica y en retórica visual, y pues hoy nos va a hablar específicamente del tema de retórica visual, que espero pues que sea pues de interés para todos. Al final vamos a tener un espacio de preguntas. Lynda va a hacer la conferencia en inglés, pero ella entiende español, digamos que tiene un muy buen nivel de español. Entonces al final ustedes podrán hacer algunas preguntas si tienen, y ella pues tratará pues de dar una respuesta a las inquietudes que ustedes presenten sobre la conferencia. Lynda, thank you for accepting this invitation, and the audience is yours. Thank you.
Gracias. ¿Pueden oírme al fondo? Sí. Para comenzar, quería agradecer a señora Cero y la Editorial Neogranadina por invitarme a dar esta conferencia. Voy a hablar en inglés, pero después pueden preguntarme en español si quieren. Okay, so today my talk is on rhetoric, which I will define for you, and climate visualization, so the graphics that we see in scientific publications and in the news about the climate and climate change and climate projections, what is anticipated to happen in the future with climate. And I want us to be able to understand these graphics as arguments, as trying to make an argument about the world and in some cases what we should do about the situation in the world. We understand arguments in words very clearly, but we sometimes struggle to understand the arguments that graphics make, and so that's what I'm going to talk about today. So first, what is rhetoric? Retórica, what is it? It is an ancient discipline, almost 2,500 years old, and it's one of its original authors, of course, is Aristotle, who defined rhetoric as an ability in any situation to be able to see what are the available means of persuasion, to persuade another person, to persuade an audience. So that's sort of the old definition. A more recent definition from this century is from Tom Goodnight, who describes rhetoric as the creative resolution and resolute creation of uncertainty. And I like that key word, uncertainty, for two reasons. One, all of us have to manage uncertainty on a daily basis. We have to make decisions all the time about things that are not 100% certain, and so we have to use our best judgment and make our best decision. When we do this as a group, that is rhetoric. when we have to talk to each other and communicate with each other about what to do, what to decide. That is the art of rhetoric. The philosopher Bruno Latour also defines rhetoric as the political speech. And this is why it's very important for climate change, to understand rhetoric and climate change, because climate change is a political issue. It is a scientific issue, yes, but it is a political issue. And it involves intense levels of uncertainty. So this is why rhetoric is so useful for understanding arguments about climate change, because they are political and they are about uncertainty, and these are the things that rhetoric does the best. So the question that I ask in my research is, what are the effects of these visualizations, these graphics about climate change? What are the effects of those visualizations on the formation of community, a group like you who have to decide something together in order to stay together? That's a community. And so what I am interested in as a rhetorician is the effects that these graphics have on the process of forming communities or breaking up communities, right? Challenging community formation. So I'm interested in the community effects of climate visualization. So that's what I work on. So today, I'm going to do two things with you. First, I'm going to teach you a Greek concept called the enthymeme. And the enthymeme is like the core of an argument. It is like the core DNA of an argument. And then we are going to apply that to graphics to see how enthymemes work visually. The second thing we're going to do today is think ahead. Just like climate scientists think ahead, we are going to think ahead in terms of what kinds of arguments may be needed in the future and may be most effective at forming communities around climate change, to take action around climate change. So those are our two tasks for today. Let's start with a very famous graphic. How many of you have seen this graphic before? Anyone seen this? Okay. This is called the hockey stick, right? Like hockey stick, right? Because it has a long handle and then a very sharp change in the bottom of the stick. So this graphic is famous in the United States because it really started the intense political debate about climate change in the US. Before this graphic was published, there were various arguments about climate change. There was a high level of uncertainty about how quickly the climate was changing and warming. And when this graphic was published in the third assessment report of the United Nations Intergovernmental Panel on Climate Change, which was dominated by American scientists, when this graphic was published, it immediately changed the political debate because it shows a very striking difference here in temperature, in the trend of temperature over time. Right? Things are kind of kicking along pretty normally, and then all of a sudden, straight up. This graphic was alarming to people on both sides of the political spectrum. Those who were environmentally aware and conscious were alarmed at the rate of temperature change. Those who were more conservative and did not believe in the greenhouse effect and did not believe in climate change were alarmed because they were worried that this graphic would convince the government and industry leaders to put restrictions on fossil fuels and on industry. So this graphic alarmed everyone, no matter what their politics were. So we're going to take apart that process and see how this graphic made an argument and try to understand why that was so alarming visually to people. So to do that, we need to talk about two different things about this graphic. One is grammar, grammatica, okay? This is the structure of the graphic. The colors, the lines, the axes, that is the grammar of the image. Then we have to talk about the rhetoric of the image. And again, that is, what does that grammar mean to people in communities? What does that mean in terms of their community values and their commitments to their community? So we have two parts that we need to look at, the grammar and the rhetoric of this hockey stick graph. Let's start with grammar. A visual grammar is a set of rules or principles that generate predictable structures in graphics like the hockey stick. We can understand this visual grammar using two disciplines, Gestalt psychology and semiotics. Gestalt principles are from psychology. How many of you have heard of Gestalt before? Anyone heard of Gestalt? Okay. The idea behind Gestalt is that all humans share some basic perceptual abilities to distinguish things from each other, to see when they are aligned, and these principles are applied to everything. They're applied to how you got into this room. They're applied to how you read on a page. They're applied to how you look at images. So the principles are here, and we are not going to go over them in great depth, but proximity is how close objects are. The closer objects are to each other, the more they are perceived as one unit. Okay, so that's proximity. Similarity, the more similar things are to each other, the more they are perceived as a unit. So on this graphic, this looks like a line to you, and this looks like a line to you. They are not lines, they are just groups of circles. But because the dark circles are similar and the light circles are similar, you perceive lines. That's the principle of similarity. Enclosure, if something is bounded or enclosed, it's perceived as part of a unit. Symmetrical things are perceived as part of one unit. Continuity, if things are lined up with each other, they are perceived as being part of the same thing. This is going to be very important for the hockey stick, so remember this one. Continuity, things that are continuous are perceived as being part of the same unit, and things that are discontinuous are perceived as being different. Connectivity and figure and ground, which means things that are close to you and things that are far away from you are perceived as being different. Okay? So these are Gestalt principles that we can apply to the hockey stick graph. Let's do that. Okay, so here are our principles. Here's our graphic. Probably you notice a few things right away having to do with continuity. There is a continuous line here going from about the year 1000 to about the year 1900. There's a continuous, relatively continuous line of temperature. It's lined up pretty much in a straight line. Then at 1900, something changes, and the line breaks. Is no longer continuous. It goes off in a different direction. So already from the grammar of the image, we know that we are going to focus right here on trying to understand what this graph meant to people and how it made an argument. We're going to zero in on the thing that jumps out at us, that is salient, right? And that is this discontinuity here. Closure of the graphic also is important here. It says this is the whole picture, right? This is the whole picture of climate, which is interesting because this graph only goes back to the year 1000, right? This is not really the whole picture of climate, but the box around the image suggests we have the whole picture with this graph. This is climate. That's sort of the suggestion that this makes. Okay, so those are the two principles of Gestalt we are going to use for later for our rhetoric, continuity and closure. Now let's talk about semiotics. So semiotics is a study of meaning, what symbols mean to people, how we derive meaning from symbols. So there are three kinds of signs in semiotics. There are iconic signs, which look like what they try to represent. There are symbolic signs, which do not look like what they try to represent. However, we have all, as a community, made an agreement that this symbol will represent this thing. So this symbol, we have agreed, represents money, even though that symbol does not look like money, right? Does that make sense? So that is a symbolic sign. And finally, we have indexical signs. Indexical signs point like an arrow to the thing they represent. They don't look like the thing they represent, but they point to it. So arrows on the street, right? For changes in traffic, right? And directions, those are indexical signs. A thermometer, where if the mercury or the red liquid is very high in the thermometer, that points to high temperature. Smoke points to fire. And traffic signals give you directions about what you should do. So these are indexical signs. So iconic, symbolic, and indexical. These are the three types of signs that create meaning in different ways. So how do we apply this to our hockey stick? So I want you to notice the change in color there. I'm not sure how well you can see it in the back, but the graph goes from being blue to being red when the temperature changes. And we associate red with hot and blue with cold. This is semiotics. This is an indexical sign where we have learned to associate the color red with heat and the color blue with cold. So that is one very, very important part of this graphic that we need to keep in mind so we can understand the rhetoric of this graphic. Okay, so that is the grammar of the graphic, the structure of the graphic. The things that are important for the grammar here are the continuity of the line, the enclosure of the graphic as representing the whole picture of climate, and that color change between blue and red. Those are the three grammatical elements that we are now going to work with to understand the rhetoric of this graphic. So, rhetoric. As I said, the most basic form of an argument in the rhetorical tradition is the enthymeme. An enthymeme is a Greek word that just means something with a part missing. That's what it means in Greek. Something that is missing a part. And the thing that it is a syllogism. So if you've taken logic, you've probably learned the syllogism, which is a form of logical argumentation. A famous example is Socrates is a man. All men are mortal. Therefore, Socrates is mortal. So does that kind of logic sound familiar? It's like classical logic, right? That is a syllogism. But when you take the major premise, all men are mortal, out, then you have an enthymeme. You have an incomplete syllogism. So now what you have is just a claim and a reason, but what is left unstated or unsaid is a sweeping generalization, a value or assumption that must be believed in order for the argument to be valid. And when I say it must be believed by your audience. So if I am going to make an argument to you and say, you know, Socrates, I have concluded, Socrates is mortal because he is a man. You have to believe something in order to believe that argument. You have to believe that all men are mortal. If you do not believe that, you will not believe my argument. Okay, so you need to supply to me that missing piece of the syllogism. You need to supply that major premise. So we have an interaction. All arguments are an interaction between me, the speaker, and you, the audience. We have to work together to make the argument. Otherwise, it will not be persuasive. Does that make sense? So it's an interaction. So let's see with words how this works before we go back to the image. This is a pretty typical argument about climate change. The argument is carbon dioxide contributes to climate change. That's the conclusion, that's the claim. Now here comes the reason. Because it traps heat in the Earth's atmosphere. Okay, so this is the enthymeme, this is the smallest form of this argument. Carbon dioxide contributes to climate change. Why? Because it traps heat in the Earth's atmosphere. Now, for you to be persuaded by this argument, there is a piece missing that you must supply from your own beliefs. And that is this. Anything that traps heat in the atmosphere will make the planet warm up, right? If you don't believe that, then we can't connect this heat to this change. If you don't believe that anything that traps heat causes change. So this is called the warrant. It's the missing piece of the argument that you must supply me from your own beliefs in order for me to persuade you using this enthymeme. All right? So this is almost never said. It's assumed. I'm assuming you believe this. I'm assuming that as technically trained, well-educated people, you believe that anything that's going to trap heat in the Earth's atmosphere is going to make the planet warm up. I'm making an assumption. I might be wrong. You may not believe this. And if you don't, this argument will not persuade you. It will not be persuasive. Okay? So you with me so far? There? ¿Más o menos? Probablemente menos. Es muy técnica. Es muy técnica, retórica, but paciencia. We'll get there, okay? All right. So, here's another way of looking at the same thing. This is the structure of this argument visualized a little bit. So when I told you carbon dioxide causes climate change because it traps heat in the Earth's atmosphere, for that argument to work, you have to believe that anything, the set of things that trap heat in the Earth's atmosphere, fits inside the set of things that contribute to climate change. In other words, you have to believe that everything that traps heat will cause climate change. So it will be a general belief, a universal belief, right, that covers all cases. So the set of things that trap heat are the set of things that cause the climate to change. This is just another way of visualizing the exact same thing that we just looked at. This is not a mathematical demonstration. This is a probabilistic argument. It is probably true. Is it 100% true? No. Every day we make decisions that have a degree of uncertainty to them. We get in our cars and drive on the assumption we will not have an accident, right? We make a deposit into our bank account assuming the money will be there, right? These things are not 100% guaranteed, yet every day we make decisions based on the probability that things will work out the way we expect them to. And rhetoric is about probability. Things are probably true, but they are not mathematically true the way an algorithm or a formula is, okay? So, you're going to try this now, okay? I'm going to give you a couple of examples, and I want you just mentally to try to represent for yourself the beliefs or assumptions, the warrants, that you must believe in order for these arguments to persuade you. Okay, so let's start with the first one. I make a claim. You should not eat that mushroom. That's my claim. You should not eat that mushroom. What's the reason I give you? It's poisonous. So think about what you have to believe about poisonous things in order to be persuaded by my claim that you should not eat that mushroom. Right? You have to believe that poison is bad for you, right? Or poisonous things will kill you. If you don't believe that, you're going to eat the mushroom. You're not going to be persuaded by my argument, right? And in the case of hallucinogenic mushrooms, many people don't believe this argument, right? They go ahead and eat that mushroom even though they know it's poisonous because they're interested in the psychological effects, right? All right, so let's try another one. So probability, not 100%, right? Let's try another one. We should have a flat tax, meaning everybody pays the same tax, everyone, no matter how much money they have. We should have a flat tax. Why? Because a flat tax treats everyone equally. That's the reason I'm giving you. Think for a moment, what do you need to believe about equality, about being equal, for this argument to be persuasive? This is a political argument, right? What do you need to believe about equality? That everyone can be equal, right? And that equality is a good thing. That it's a good thing that everyone should be treated the same. Does everyone believe this warrant, that everyone should be treated the same? In my country, no. There are many people who believe that rich people should pay more taxes, and poor people should pay less taxes. So they would not hold that warrant about equality, and they would not be persuaded by this argument. Okay? So you can, understanding a little better now? Okay. All right. Good. It's complex. You're doing really well. Let's talk about images now. Let's go from words to images. This is a very famous photograph, a very famous image that was taken during the Dust Bowl. I don't know if you know about the Dust Bowl, but this is a period in American history where the climate changed in the 1930s for a short period of time. And in combination with over-farming, with too much farming, the entire Midwestern United States became very dry, and crops died, and there was no water, and people died. And this was called the Dust Bowl, and it helped cause the Great Depression of the 1930s, the Dust Bowl. So during this time period, this Dust Bowl, a photographer took this image, okay? Now, I want you to notice a couple, let's do our grammar and our rhetoric of this image, and then we'll get the argument. So, grammar. Notice the closure of the image. It's very tightly enclosed around the dry dirt and the skull. That closure, remember I said closure says, this is the whole picture. And so the assumption here is, this is the way it is everywhere, right? This is the Dust Bowl everywhere. Of course that's not true. This was taken in a very close focus of an area about this big, right? But the way the closure works is there is an assumption that this is the case everywhere in the Midwestern United States. Okay? So now that we know that, and by the way, we have a skull. So let's do a warrant here. Are skulls a positive, happy thing, or are they a scary, bad thing? Scary and bad. So you have scary, bad thing, plus this is everywhere. And you can see now the argument of this image is coming to you. It is, the Dust Bowl is very bad, and it is killing animals and people everywhere. That is the argument made by this image. And this image was a very powerful image politically. It was instrumental in getting the United States Congress to allocate relief funds for farmers in this area. This image was so powerful that it was very powerful in getting help sent to these farmers. So that's how images can operate. That's how they can be that powerful. So now it's time to return to our hockey stick at last. Armed with what we know about the grammar of this image and the rhetoric of this image. So, as we already said, you have the discontinuity, right? We notice that. We notice the red color, which is alarming, just like the skull. Alarming, it's bad. We have the closure saying, this is it. This is the whole climate. Now, if we put that together, we can verbalize an argument. That argument can be phrased like this. Average global temperature started warming anomalously, meaning shockingly, right? Very differently, around the year 1900, right? If we go back to that graphic, 1900 is right about here, right? So we say, started warming shockingly or anomalously around 1900. That's the claim made by that line, the discontinuity in the line. Why? How do we know this? What is our evidence? What is the evidence behind this graphic? Well, it turns out, this is information I know because I've read this report. The evidence for that model that created that line comes from thermometers, only in about the last 150 years. Before that, the evidence came from tree rings, corals, and ice rings. Have you heard that some of these are used as proxies, as ways of measuring temperature when we don't have thermometers? These are pretty standard scientific ways for figuring out what the climate was like before people were around. How thick is a tree ring? How thick is the ice layer? What is the coral death and growth like? These are proxies that climate scientists use to support their arguments about climate change. Okay, so this graphic says something changed around 1900. How do we know this? Because we have been tracking temperature this whole time using these sources of data. All right, what do you need to believe that is not being said in order to be persuaded by this claim? You need to trust those sources of evidence. You need to believe that tree rings, ice layers, and corals are reliable indicators of temperature before we had thermometers. If you do not believe that, you will not be persuaded by this argument, and in fact, that's exactly what happened with many skeptical people in the US. So, once people became skeptical, they returned to another, I'll go back to this. Okay, so the people who were skeptical said, you know what, I don't trust your techniques here. I don't trust the tree rings, I don't trust the ice cores. I think you guys were making this up in order to make a point. And these skeptics came up with what they called the reverse hockey stick, right? Here's the hockey stick, and they overlaid it over a reanalysis of the temperature data. And look, it goes down instead of up, right? So the skeptics are using a graphic to argue against a graphic. This was the political argument between these two graphics. I want you to notice something that's really important, though, which you probably can't see from where you are. This graphic goes back to the year 1000 AD. This graphic goes back to 1980. So the skeptics only reanalyzed data from the last 30 years when they made this graphic. And furthermore, look at the variability in the data. There is not a strong continuous line in these data, right? But they use the hockey stick to create a sense of continuity to their arguments. They're using visual grammar to make an argument that says, this graph is wrong, and we are right. So then, Michael Mann, who made the original graphic, this one, he made another graphic. And he said, oh yeah, you don't believe my graphic? Well, here's another one, right? And it goes back to 10,000 BC, right? You can almost like hear the mic drop, right? This graphic goes to 10,000 BC. And look how strong the colors are now. So the uncertainty has been removed. You have a very strong line without much variability. And you have a very strong change in the color. So he's fighting back with even stronger visual techniques. Stronger color, stronger line. Right? All this argumentation is happening visually, not verbally. Okay. I'll skip over these, I think, for now. What you're seeing here is a change over time in how some of these graphics, the color in these graphics has changed. So I'm just going to flip through them, and I want you to just notice the change in color. Right? It's like a bruise spreading on your skin, or a fire getting hotter and hotter, like metal getting hotter and hotter in a fire, right? So the colors here are being used to intensify that sense of danger and alarm in these graphics. So these are from similar reports as the hockey stick. Okay, I'm going to skip these. Okay, so that's the basics of visual argumentation for climate change. You want to pay attention to things like the change in a line is very important. You want to pay attention to color, and you want to pay attention to the scale or the enclosure of the image. And these are the tools that will help you understand how that graphic is making an argument, what argument that graphic is making, right? You work from anything that jumps out at you to try to interpret that in terms of politics. So just to go back for a moment to the hockey stick, what happened was not just that a great change was noticed at 1900, people started asking a question, a very common sense question about that change, and that is, what caused it, right? What caused the line to suddenly change? This is a very natural question. It has to do with a different part of argumentation that I don't have time to get into, but it's a very natural question. What caused this? And the UN IPCC and the other climate science organizations said, well, you know what changed around 1900? We started burning a lot of fossil fuels, right? That's what changed. We weren't burning that many fossil fuels before that time, and then we started burning a lot of fossil fuels for industry and for home heating and things like that. So that's what changed, and that is probably what caused the change in temperature. Now, logically, that argument is really problematic. It's really complicated, because those are just two things that are correlated. They're correlated at a moment, but there is not necessarily proof that one causes the other. So there's a complicated process of looking at all of the different changes that happened at that time and deciding which ones had the biggest impact on that line. It's a complicated process, but when scientists looked at all the evidence, they decided fossil fuels were probably the thing that caused the line to change. And so now you can understand why skeptical groups in the United States got very upset by that graphic. Those skeptical groups were funded by, any guesses? The fossil fuel industry, right? Because they didn't want to start burning less fossil fuels. They didn't want to have their economics damaged by climate change policy. So they put a lot of money into creating graphs like this one. They spent a lot of money funding research of skeptical scientists to produce graphs like this one to visually argue against the argument that climate change was being caused by fossil fuels. Okay. So to finish, I want to move on to what next. If the hockey stick is sort of our past and our present of arguing about climate, what's our future? What is the future of arguing about climate? And I'm really excited about this because I have been learning a lot about alternate ways of visualizing climate and arguing about climate that come from some of the communities who are most affected by climate change. So indigenous communities, right? Communities of people without great resources who are perhaps farmers or fishermen. So some of these communities actually have their own traditional ways of imaging, of visualizing, that I think can be very promising and very powerful for finding alternate ways to visualize climate that may be more persuasive to skeptics, right? Because they rely on different assumptions and different values. So I'm just going to give you a couple of examples of what I'm talking about. We'll skip that. So the graphics that I have showed you so far are what are called, they see climate globally, all right? So globally means like the world at a glance. Notice this enclosure that says this is the whole world, right? So these graphics are global. They see the whole world in one glance. And that's this, you know? As if the viewer, whoever made the graphic, is up in a satellite looking, or like God, right? Looking down at the whole world. That's what all of these graphics that I have shown you have, this global aspect. Like, this is all of climate. This is all of the world, right? And they form the boundary and they say, this is it. There is actually a very different way of visualizing climate from this global way, and it is what is called a spherical way. A spherical visualization is what all of you are experiencing right now. Your world, your perception, your visual and your sensory perception is spherical. You are at the center, and the limit of your ears and your eyes makes a sphere. And that's how you understand climate. Your climate right now is in this room with air conditioning, with the noises, the people around you, the way you're feeling, the way your body feels right now. That's your view of climate. It's spherical. And so researchers like me are trying to understand how better to articulate or combine these global satellite type views of climate with your spherical experience of climate to make more persuasive images. And we're taking inspiration from the communities who are most affected by climate change. These communities include, in North America, Arctic communities who have their own way of visualizing their environment, their space. What you see here, that's a map. This piece of carved bone right here is a map. It is a map of the coastline. It is designed to be held in the hand of someone paddling a canoe. In the dark, they can feel the outline of the bone and know where they are along the coast by which bay they have gone into. So it is designed to be used by their body in a specific place. It is not a top-down view like this map. It is a spherical view of their experience moving in and out of these coves. Right? So a very different way of visualizing the environment. Very embodied, very tactile. This is, I don't know, have you seen these? This is a navigation chart that is used by Micronesian people. It is again carried with them in their canoe. It's not a GPS on their phone. It is not a satellite image. It is carried with them as they paddle. And what these lines represent, that they can feel even in the dark, are ocean currents. And if you have learned anything about how these folks navigate, they will put their hand in the water next to their boat and feel the current. And then this is a map of the currents. They know which direction they will head. The little shells, these are shells on the map, those are islands. So they can feel the bumps of the islands and they can feel the currents just as they're feeling them in the water. Again, this is a spherical view of climate. This is not a global view of climate. Finally, the research I've done the most with is the climate images created by Australian Aboriginal artists. So while these look like beautiful abstract paintings, they are in fact maps of climate. This is a map of water holes, right, of ciénagas, and how they dry up and how they change over hot season. This is wet season, right, and this is dry season. So this is actually a map of how these change over time. This is incredible. It's so complex, I could take an hour and try to explain it to you and I wouldn't be able to. But this is both a story, a myth, right, a legend, about 7 sisters who try to escape this very bad old man. So it's both a myth about that and a map of where you can find key water holes and food sources in the area where this Aboriginal group lives. And this story can be told by different Aboriginal groups and mapped to different water holes. So it is flexible. From culture to culture, it can be transferred, and it is flexible as a record of climate and environment and a guide to help people survive in that climate and survive climate change. Because this is climate change, and this is also climate change. And Aboriginal people in Australia have been making these images for 50,000 years. 50,000 years, right? That goes way beyond Michael Mann's hockey stick map. It goes way beyond our thermometer measurements, which only are about 150 years. 50,000 years. These people have been making these climate maps, not in acrylic, they've been making them in other media, but they've been making these accounts of climate for 50,000 years. Don't you think we have something to learn, perhaps, from these groups of people about climate and about climate change and about how to adapt to climate change? So these are the kinds of visualizations that get me really excited. The charts and graphs are great, and it's important to understand how to read them, but what really excites me is the future potential of working with vulnerable communities to create other kinds of images of climate so that we can work together to adapt and mitigate climate change. So here's another example that contrasts a global view of Australian climate with an Aboriginal view. This view is useful to the people who created it. It records family relationships, climate relationships, and historical relationships. This view is not useful to those people. They show up on this map right there. That map doesn't mean anything to them. This means something to them. So, like I said, we need some of these alternate ways to depict climate and to depict climate change. And we need to articulate these with scientific images. I'm not saying we should get rid of the global images, but they have to be articulated with spherical, local images in order to be effective in helping communities adapt to climate change. Okay, thank you very much.
Gracias, Lynda. ¿Hay alguna pregunta del público? ¿Tienen algún comentario que quieran hacer o alguna duda sobre algún aspecto de la conferencia?
Gracias. Hola, buenos días. ¿Te puedo hacer la pregunta en español?
Sí.
Ok. Primero que todo, muchas gracias por tu presentación. Es realmente interesante lo que las gráficas pueden llegar a mostrar más allá de lo que uno normalmente entiende. Mi pregunta va hacia el último ejemplo que mostraste, que según entiendo, la gráfica de la izquierda, donde estaban como las líneas, los jeroglíficos, mostraban más información que el mapa de Australia.
Sí.
Me gustaría saber por qué, o desde qué punto de vista.
Sí, so, the question is about, well, you all heard it. So the reason it shows more information is a very important reason. That image actually articulates, yeah, thank you. This image is a combination of archaeological information that was acquired from science done in that area, and that is this part. This represents, let me say that this information is heavily coded and secret, so I do not know all of it. It is particular to these people, and a part of this graphic encodes secret information about clan relationships, tribal relationships, moral relationships that I do not have access to. But the part I do know is that this part of the graphic represents the archaeological findings that actually demonstrated that this people group had been in this area for 50,000 years. So this is under the ground. These are bones, these are findings. Above here is the present. So it is the current relationship of people to each other. It is actually food sources. These are food sources in here. And so it maps food sources, clan relationships in relationship to what science has demonstrated about the longevity of these people in this area. And most crucially, this graphic refuses to separate science and culture. Yeah. So it says, and it refuses to separate climate and people. They're the same. So whenever a person does something, it has an effect on the climate. It pulls on the climate. And whenever the climate does something, it pulls on the people. And that is how this graphic is different than this one, right? this kind of top-down objective view separates climate from people and separates science from daily life, from family relationships, from clans and tribes. So this divorces those things, and this integrates or combines them. And this is the primary way in which this graphic is more effective, because it makes an argument that whatever we do affects the climate, and whatever the climate does affects us. Does that make sense? Yeah, thank you. It was a great question.
Okay, so hello.
Hi.
I have a few questions. I would like to ask you, what is the elder registers of these graphs, or the first registers? You say that is around 50,000 years ago, or there are like more older, or something like that?
Yep.
Are those? Okay, and the second one is where was the Dust Bowl photo taken?
Oh, where was the, okay. So yeah, so these graphics, this image was made very recently, in 2006, by a collective of women. So it was actually created by a group of women, 7 women who created this graph. But the story of the 7 sisters is an astronomical story, so it's 7 stars in a constellation, and that story is 50,000 years old, roughly, as far as we can tell. So, we don't know exactly, but the story has been told as long as this group of people has been around. So that's roughly how we know that. And the Dust Bowl photograph was taken, I believe, I'm not 100%, but I believe it was taken in Kansas, the state of Kansas, which is it was right in the middle, it was epicenter for the Dust Bowl. Yeah.
Thank you very much.
Thank you.
¿Alguna otra pregunta?
Primero que todo, buenos días. Tú mencionabas como al final que en las nuevas sociedades debería tratarse como de usar ese tipo de representaciones, no tanto como los mapas. ¿Cómo creerías tú que en sociedades que solo se usan los mapas se podría aplicar como ese tipo de representación más abstracta, digámoslo así?
Sí. So for societies like mine that only use this, right? Is that what you're asking? Is like for the US that uses those, how can we bring in some of these other representations? Like how can we change that? Something more abstract? Is that what you were asking?
Yes.
Okay. That is a really good question. I have a colleague and I are working on exactly this issue. We are working with a platform called Global Forest Watch. I don't know if anyone is familiar with it. It is a online platform that shows you all the forests in the world, but you can also zoom in to where you live and see specific information about deforestation or reforestation. And there's different layers you can load on the map. So it's an interactive platform. And while that is interesting in and of itself, it has problems that I didn't talk about. But what's very exciting for us about that platform is it allows people on the ground to upload their own stories and their own images. So if a villager is going out and sees some illegal logging, sees smoke, and goes and investigates and sees that people are cutting trees where they should not be cutting trees, they can take a picture with their cell phone and upload it to this platform. So it then becomes information that the other villages in the area can use to intervene in that situation. People can also upload stories. So they can upload images like this one, and myths and legends and stories about what the climate means to them. So this is why we are excited about that platform. It's because it is a very scientific platform, but it makes space for some of these alternate ways of talking about climate and visualizing climate. So those are the kinds of ways that we hope we'll be able to articulate the global and the spherical views of climate. Does that make sense? Yeah, thank you.
Hello.
Hi.
I have a question. So it depends on the picture that I want to show to some people. For example, I'm working in some project right now, and I have some data. So depending on the people that I want to show the picture to, I have to represent that. I mean, maybe for some people this graph probably means nothing or probably is confusing, so I need to check who I'm going to show the picture to in order to make the graph or something like that?
Yeah, absolutely. Yes, exactly what you just said. So you, as specialists, we have a very bad idea about what is understandable to other people, right? Like, for instance, I gave you this talk about argument. This is very simple stuff for me. This is the first time many of you are hearing this, and it is very difficult. It is very technical, right? So as specialists, we lose a sense of that difference between what we know and what our audience knows. So you are 100% correct. You need to figure out to whom you need to show the graphic and ask them, hey, does this make sense? Does this color scale work for you? Do you know what I'm trying to say here? And you can try to design something that you think makes the argument you want to, like, hey, notice this change, or look, notice this difference between these two bars. And then show it to someone that is in that community and say, do you see what I'm seeing? And then take notes, right? And make changes to your graphics. So again, it's about being in community. It can't be abstract. It can't be philosophical. It's about interactions with real people in real communities. That's how this kind of communication gets better. Yes, thank you. That's a great question.
¿Alguien más?
Es el tiempo de almuerzo.
Son muy tímidos.
Gracias a todos.
Muchas gracias a la audiencia por asistir a la conferencia. Espero que haya sido útil.